Hey guys, Medics Tutor here again. Today I'm gonna be teaching you guys how to factor out numbers to find their roots. So we'll be starting off with a question, but we'll start off with 196, the square root of 196. So you guys might be wondering, how would someone solve such a question? So to solve this question, we would actually find the prime factors of this number, and we would start from the lowest number and we would go up. So first, let's say, we can see that 196 is divided by 2. So you put a 2 here, and we go up by 2. 196 divided by 2 is 98. We know that this is divided by 2 too, so we put a 2 here and we go up by this. 49. Now we can see that the last number of 49 is not even, so it's not divided by 2 anymore. So what other number is there that 49 can be divided by? Is it 3? Nope. Is it 4? Nope. Is it 5? Nope. Is it 6? No. Is it 7? Yeah. So if you want to use this method, you must know the divisibility rules, which I'll be making a video on very soon. The divisibility videos will help you with this method called factorization. It becomes 7 and there's 7 here. Now what you want to do? Now you'd want to go look for pairs of 2, because we're looking for pairs of 2 because it's a square root. So we're going to look pairs of 2. This here is 7. This here is a 2. Now we multiply these and get 14. So now we know that 14 squared is equals to 196. Another question we could try solving is 484. So for this question, we would divide it by 2 first, which gives us 44. 2, 2, 4, 2, 2. And then we can keep dividing it by 2 until we get to 121. Now, once we're at 121, we can see that this is no longer divided by any other number. So what other number could there be? Well, we could use 11 here, which would turn this into an 11 too, leaving us with 2 11s and 2 2s, giving us the value of 1. We can pair these numbers up because if you're square rooting it, this becomes 2, this becomes 11. 11 into 2 equals 22. So we know that 22 squared is equals to 484. Now, the reason why we're taking 2 pairs here whenever there's a square root here, the reason why we're taking 2 pairs all the time is because anytime, let's say 8, right? Let's say you want to find, actually, we'll be taking a better example of 16. Let's say you want to find the 4 root of 16, right? So what does 4 root mean, or 4th root? So this means 16 has to be equal to something raised to 4, right? This means x into x into x into x 4 times. Now we're gonna look for a number that when multiplied 4 times gives us 16, which is gonna be 2 into 2 into 2 into 2. So when we pull out the prime factors here, it becomes 2, this becomes 8, this becomes 2, this becomes 4, this becomes 2, this becomes 2, and this becomes 2, and this becomes a 1. Because remember guys, we're dividing it and bringing it down, dividing it, bringing it down, dividing it, bringing it down until the number here is 1. Now we make pairs of 4 because there's a 4th root here. So we get 1, 2, 3, 4. So there's pairs of 4 2's. So we know that when 2 into 2 into 2 into 2, the answer is going to be 16. Therefore, 2 raised to 4 is equal to 16. And 16 is equals 4th root of 16 is equals to 2. Right? Now, we could do the same. We could apply the same. We could try doing the same method, but instead we're gonna try doing the square root of 16. So this becomes 16. Alright. Now we try figuring out what number when multiplied twice makes 16. So we'll make the pairs here 16. So we get 2, then we get an 8, then we get a 2, then we get a 4, then we get a 2, then we get a 2 again, 2, and this becomes 1. So there are 2, and this time we're looking for pairs of 2, which are 2 here. So what this just means is why we're looking for pairs of 2. Here we're looking for pairs of 2 because there are 4 pairs over here. We want this 2 and these 2 all the time. So this becomes 4 into 4, right? 2 into 2, right? So now we know that the square root of 16 is equal to 4. I hope you guys understand till here. Now, that's the logic behind this factorization method. So now we'll be getting into some extra practice questions. Another question we could tackle would be for the cube root. Now we'll be finding 512 cube root. Let's see if you guys can pause the video and try it out for yourselves. Alright, now we'll try solving this. Factor of 2. Be factored by 2 again because it's an even number. We can factor this by 2 again because it's an even number once again. Sorry. Becomes 2. We can factor this becomes 64. We can factor this by 2. It becomes 32. We can factor this by 2 again. This becomes 16. Factor it by 2 again. It becomes 8. Factor it by 2 again. Becomes 4. Factor by 2 again. It becomes 2, 2, and there's a 1 left. Now, as we know, if we were finding for the 4th root, if we were finding pairs of 4, right, like we did here, and if for these, and if for a square root, we're finding pairs of 2. For the cube root, we'll be finding pairs of 3. So there are 3 2's here, 3 2's here, and 3 2's here. So you know it's 2 into 2 into 2. Therefore, the answer to this is 8. Because 2 into 2 into 2 is equal to 8. Another question we could try would be for the 5th root. We could try finding the 5th root of 32. You guys can stop the video and try solving it out for yourselves. Alright, now we solve it together. So there's a 32 here. We take a 2 out here. This becomes a 1 6 because it's an even number. We divide it by 2. It becomes 1 6. It's an even number again, so we can divide it by 2 again. It becomes 2, 8. We can divide it by 2 again. It becomes a 4. Divided by 2 again becomes a 2. Divided by 2 again becomes a 1. So we know that if for the third root we're taking pairs of 3, and for the fourth root we're taking pairs of 4, for the second root we're taking pairs of 2, for the fifth root we'll be taking pairs of 5. So this gives us 1, 2, 3, 4, and 5. So we know the answer is 2. Since there's nothing else to multiply with 2, the fifth root of 32 is 2 itself. Now, we'll be doing questions that give you mixed radicals. So, what mixed radicals are? Radicals are these expressions you see on the on my whiteboard right now. Mixed radicals are whole numbers with these radicals. For example, you could get something like this, something like this. So what this just means is whatever the radical for 8 is, you multiply it by 2. But guys, you guys have to keep in mind, if this 2 was inside this, that just means it's a square root. That just means it's the second root of 8. But if it was outside it, like this, if it were like this, that means you'd multiply the square root of 8 into 2. So these are mixed radicals where there's a coefficient to the radical. So mixed radicals, coefficient plus radical. Radical is anything with a root sign. I hope that's clear to you guys. So now we could try solving some questions that would give us mixed radicals. So one of the questions is 50 square root. So you guys can try solving this question by yourself once, and we'll take over it. Alright, so to solve this question, I would first, I know it's an even number because it ends in a 0, so I'll go by 2. Oh, that gives me a 25. Now, I will go with a 5 here, which give me another 5, so I'll go with the 5 here. 5. Now, the thing is, I have 2 5s here, and just 1 2, which is left outside. So what would I do, you guys might wonder. So for this, I would take this 5, because it's a pair of 2, right? Since it's 5 into 5 into 2, and this is what it's basically saying. The square root of 5 into 5 into 2. We know that the square root of 5 into 5 is just 5. So we have square rooted that, and now we're left with 2. You guys might want to remember that. That's like the major logic behind this method. Another question we could do is cube root of 128. This is the last question. This is the last question we'll be performing. And so cube root of 128. So you guys might want to try it by yourselves once, and then we'll be doing it together. You guys can pause the video here. Alright, So the cube root of 128. So how will we solve this question? We can see that this ends in an even number. So we'll take 2 out of here, becomes 64. Correct me if I'm wrong in the comments. This becomes, we take another 2 out here because it's an even number, so it becomes 32. Take another, then we take another 2 here, sorry about that. This becomes 16. We can take another 2 here, becomes an 8. Take another 2 here, becomes a 4. Take another 2 here, becomes a 2. Take another 2 here, becomes a 1. Now we can try finding pairs of 3 here, which are this, 1, this, 1. So what this question is asking us is, it's basically saying cube root 2 into 2 into 2 into 2 into 2 into 2 into 2. So it's basically saying cube root 8 into 8 into 2. The cube root for 8 is 2, so we can take 2 out and we'll leave this 2 in here. This becomes a 4. This becomes a cube root 2. So that's how you solve mixed radicals and radicals questions using the factorization method. I hope this video helps you guys. Like and subscribe if